Testing sound. That works. All right. Ah, all right. I need to figure out at some point why uh, this little bit over here of the screen is still not showing up. I'm going to have to fiddle with OBS to figure that out. But not now. Now we're going to go here. I have made some changes. Can't remember where I was last time. Made a bunch of changes. Split these out so that these I'll call methods instead directly, which simplifies this module. I'm sorry, the module. Also, I added this module name to path. I can't remember if that was there last time or not. To translate module names into path names. Um, the other thing that I did is, well, process command bundle is a lot simpler now because it just calls the handler here. And so, yeah, that makes it much clearer which code is part of which thing. Now, import module. The proper answer to this, I mean, is, well, not the proper answer. Saying just okay kind of works, as long as we are careful about the modules that we compile. Oh, no, actually, sorry, it doesn't work. Import module requires uh, requires a path name response. Um, and so we're going to fix this to not just be okay. I'm going to fix it to be why does it think it should be words one plus words two colon? What? No, I don't know why you think it should be that. That's not right. Um, here, process handler. So this should be good enough for a lot of things that I want to do here. Let's look at the modules here. I have bottom, which requires middle A and middle B, and then middle A and middle B. Uh, oh, no, that's not what I wanted to do. There. So middle A uh, imports top, and middle B will also import top. Um, and top does this. So no. Opt local. I need to comment this someplace. Wonder if I have it in the build.ninja file right now. Modules TS. F. Well, that's interesting. All the stuff that writes things to the command log was taken out. That's very annoying. So let's see here. Protocol engine. Yes. Something seems off here. Well, let's see what happens. Something weird is going on here. So why are none of the print statements being hit? Right? Like this should very definitely be printing to the command log. Why is it not printing to the command log? Okay, false. Yes. All right. So that's hit. Then why does that not make it to the command log? Oh, is it that it's not flushing? I bet that's the problem. Let's try that. Huh, that's annoying. All right. All right. Now let's try this. Well, it should have recognized module import. Ah, that's the reason why. Indeed. All right. Well, no, that should have worked. Oh. All right. Aha. Well, let's see here. Let's look at modules bottom.cppm. Oh, yes. There we go. Oh, and it's not top. It's and it's not def module only because it's not an interface file. All right. And then MAPS and MBPS. And then okay, so what happens here if we do all right. Let's see here. Hello there. How are you there, side code? Hmm. It's very interesting that it leaves these undefined because they aren't. Oh, oh. Did I do that? I probably shouldn't have done that. So middle A should be export inline. That's what that should be. And middle B should be export. And then we will have, which one is it now? I'm doing pretty well. It's interesting. I like G++ Gnu's, or GNU's, yeah, G++'s module mapper idea. I don't know how widely implemented it is. I don't think Clang does anything similar. The module mapper is basically an external tool that GCC calls out to whenever it wants a module. It says, hey, where do I find this module? And one of the things the module mapper could choose to do is actually compile the module, um, which turns it into something of a build tool, which is interesting. Um, so yeah, that's what I'm doing is I'm making this an implementation of the module mapper in Python right now, and I'm testing it out to see how it works. Uh, it doesn't do recursion yet. Recursion, as in when it's trying to build a module itself, it might then get called back to build another module, and so it doesn't handle that case yet. And I'm trying to figure out how to make it handle that case. Um, yeah. But right now, what I'm doing is just going through everything in dependency order to see what happens. Um, and it looks like print something and print something twice are undefined. Did I make this? Oh, I should make this inline. It needs to be inline. It's actually something that the compiler should warn me about, honestly. Uh, and then, yep, there we go. Now all of these are defined someplace, but it doesn't say exactly where they are defined. Uh, the only thing it says is undefined is it actually, well, this is interesting. So let's try the disassemble. Ha. Huh. I think they've all been inlined is what I think happened. But the only symbol it's referencing is print something, which is undefined. And it's in top dash impl, which, yeah, right here, print something. So let's see here. dot o dash o. Uh, that works. Yep, that works. That does exactly all the things I thought it would do. Let's see what happens if I do dash. Main. Top impl, print something. Build main mod test. Source main mod test, build. I want to do dash S. What does this assembly language for this look like? Yeah, I it's kind of interesting because this is kind of a refinement that has been needed for G++ or for C++ for a long time. This kind of integrates the build system and the compiler in a way that's very similar to the way it gets integrated with stuff like Rust. And it almost has to be because the dependencies can't be known until compile time. And so the compiler has to actually start compiling it before it knows what the dependencies are. So it needs to have a way of building those dependencies dynamically as things are being compiled. Rust and Go handle this pretty well. It's not a non-issue for things like JavaScript and Python because they just don't. Yeah, it's not. They do compile. JavaScript never explicitly caches the results of its compilation. Python does, but all of that's handled internally. They're made to look as much like interpreted languages as possible. And Python in particular, when it compiles to a bytecode. And that bytecode is not at all very close to any kind of assembly language. It has high-level instructions that are very complicated. I think something like the module mapper idea that G++ has almost has to do this. Yep. And the thing is there's other things that have needed this too. Like there are a bunch of things that have been a lot simpler to implement. The original idea of templates was that the compiler would spit out all the templates that were needed to be instantiated, and then it would run through all the code and do a template instantiation pass. That was like the original idea of what you would do with templates. And it just was unworkable at the time with the tooling available. And so that never happened. But modules are basically kind of that. And LTO kind of needs integration between the compiler and the linker that is foreign to the normal compilation process that C programs have gone through. So it's kind of interesting. Yep. Well, that's what modules are. The reason why I'm interested in modules, I have this big project that I want to work on. And this big project, I've done some work on it and I've built kind of a proof of concept that yes, it can work, sort of. Um, and the idea is to completely divorce G++ from libc, like completely, and also strip out parts of the C++ standard library that don't make any sense if you don't have libc anymore. Um, and the system call interface would still exist, but the system call interface would now be inline assembly, like inline assembly functions. Like it would no longer be a function call, because right now there's a whole lot riding on the fact that every um, every system call is a function call, because when the compiler makes the function call, it has to any kind of memory that might be accessible to that function, it has to make sure that that memory, the actual memory on the memory chips, or now not really, what the CPU sees as what's in memory is the same as what the compiler virtual machine would consider to be in memory. Because C++ makes no guarantees about that much of the time. It makes no guarantees that a variable that you say is in memory actually has its value written out at any given point in time in your program. That variable might be completely elided from your program, for example. Any number of things could happen. The uh, compiler, the C++ abstract machine idea of what's going on and what is really going on at the CPU level, they don't have to correlate very strongly at all, except at very certain points in your program, they have to correlate in certain ways. And one of them is when you make a function call, because C can't see through the function call, the compiler can't see through the function call, it has to make sure that the state of memory reflects the C++ abstract machine's idea of what should be in memory at that time. And there's a whole lot riding on that for system calls to work right now. System calls have to be a function call in order to make sure that memory shows up the proper way when the system call is actually executed. When the syscall instruction is actually executed. Which means if I make them fully inline, I have to fiddle around with a lot of that. But the reason why module support was important if I want to do this is that I need to use all the constants from the Linux header files to implement this. And so, yeah, but I don't want to expose all those pound defines to the programs that are actually using this library. There should be a firewall, and modules enable me to create that firewall. The module, I can include a header file, and it can have all the pound defines it wants and all kinds of stuff. As long as it doesn't try and export anything, it's just fine. And header files don't export things because that's not a C keyword. And so all of the symbols that are in the header files will be completely invisible to anything that imports the module. And all the pound defines that the header file defines will be completely invisible. And so I can firewall off all of that stuff and not have any accidental dependencies on libc. And so that's what I want to use modules for, and why I'm spending all this time fiddling around with module support. I've been waiting for module support to get to a point where I can do that. I had a previous project where I was in fact going to write Python programs that would actually implement the CP processor in Python. So then I could actually extract the results of expanding the C++, the macros, from the header files, the pound defines. And also, of course, some pound defines are like function pound defines, right? They're macro expansions that are more sophisticated, that have parameters, and the Python would have had to handle that. And kind of didn't like that idea very much. It added an extra compilation step that I would prefer not to be there. It also introduced the possibility that my Python program might not do things exactly the right way, and so it's a source of error. It was just kind of a kludge, and so I kind of stopped doing it. But that's my was my original thought. Get a Python program that extracts all of the constants and then writes out a C++ file that has them all defined as being constexpr or whatever. Um, yep, I've been kind of waiting. What I did is actually there's a bug. I don't know if you follow the bug in the GCC Bugzilla, but there's a bug in GCC Bugzilla that's the module support bug, and it has a dependency on every bug in GNU's module implementation. And I've been watching those bugs just get fixed, and then new ones get added and they get fixed, and new ones get added and they get fixed. But I get the impression from the kinds of bugs that are showing up and the rate at which things are being fixed that the GNU people are pretty serious about module support working properly, and that it is actually uh, pretty mature. It's just that from a build tool perspective, it's not, which I'm happy writing a Python build tool. Yeah, I was kind of following it closely because that project, I call it POSIX PP. That project is important to me. I really do think that C++ should be lifted out of the C runtime environment, um, and the whole thing should be re-envisioned as no longer being like, oh yes, C++ is just kind of C with extra stuff, right? C++ is kind of ceased being C with extra stuff a long time ago. It being able to still link against C programs is pretty darned useful. And it's not a property that I want to make go away necessarily. Uh, but I would like it to be possible to write a pure C++ program that does not rely on libc. One of my other big complaints about libc is Erno. Erno is an absolutely terrible design choice, especially in a multi-threaded environment. And C++ can do a lot better than Erno. C++ can do like what Rust does with the combined error and real value returns with enums, with Rust enums, which are basically the same thing as C++ variant types. Anyway, um, so that was my POSIX PP project and why I got into modules and why I've been paying attention to where module support is. And that's I finally decided, okay, it's time to try and tackle this problem. So that's what I'm doing now. Anyway, this is interesting looking at the assembly language output. It's very clear that everything got inlined except for that print something function, which that's as it should be. That's how that should work. Um, what I'm really curious about is an inline function that's a little more sophisticated. Um, that can't actually be inlined. Trying to think how to make a C++ function that is small enough that you could conceivably have it be inline, but in fact make it not inline at all. Make it be something that the compiler just won't inline. Well, one thing I could do is -0 everything. Well, let's try that. Uh, so let's see here. Try this with so right now I'm going to have to, the way that GCM cache, I'm going to have GCM cache. I'm going to have different GCM caches for different build flags. So what I'll just do here is I'll just wipe it out. But that's a part thing I'm going to have to implement. Um, oh, oh, there. All right. And I just made the same mistake again. Uh, oh, I'm going to ask an AI. More, well, maybe I can just use man. Let's see. Oh, this is interesting. Member functions defined in their class definitions are not implicitly inline for modular code. Huh, how interesting. I'm going to have to keep this in mind. This is actually, that is a big difference. I didn't know that that was true about modules. Member functions defined in their class definitions are not implicitly inline for code that's in modules. This is different from traditional C++ behavior for good reasons. However, it may result in difficulty during code porting. This option makes such function definitions implicitly inline. It does, however, generate an API or an ABI incompatibility, so you must use it everywhere or nowhere. Uh, so yeah, that is very interesting. Um, so what I want to do is want to turn off inlining completely. I bet inline limit does it. So I'll try inline limit equals 1. Okay. And I made a mistake here, but this is an easy mistake to make. Let's see here. Da, 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 da. And source top impl. Let's see here. And I didn't need dash C here. I wanted it here, but I'll put dash S here and then see what happens here. So do we actually get implementations? Yes, we do. And we get them as weeks. That's very interesting that we get them as weeks. That means that we get the same issue with one of the things that kind of irritates me about the way C++ gets compiled these days is that essentially the same function definition is emitted in multiple object files, and then the linker is given the task of just picking one. And it does that with weak symbols, which are basically symbols that are allowed to be defined multiple times. And then the linker is supposed to just pick one definition. And modules don't fix this. It still happens because we can see here MAPS, which is a non-inline function, a function I forced to not be inline. That's a very simple function, is still stuck here as a weak function. And there will only be one definition of it in here because because this whole project is very simple right now on purpose. Um, this is just a test, but effectively anything that imports middle A and then tries to use one of the functions from it will end up emitting a weak implementation of that function. Now, hopefully, of course, because of modules, that can be a lot faster, but it's still a thing, and it's kind of annoying that it's still a thing. It seems like it could do better. For example, like when I was doing those module compiles, I did do F modules module only, which I don't know if I need to do that if I'm compiling a module interface file. But maybe if I didn't do that, the O file would be created because otherwise the compiler wasn't creating the .o file. Maybe the .o file will be created and it will have a definition for the inline function there. But I bet it would still emit the weak symbols everywhere. It's kind of annoying. Anyway. Uh, yep. Both of these rely on libc++, of course, and they're shared, same set, different ordering, which is interesting. No, same ordering. Okay. It just looked a little deceptive. It looked a little bit like it might be different ordering, which would have been kind of weird. That works just great. Let's see. What happens if I turn off module only when I do this? And I build bottom here. Ah, I do get a bottom.o. What's in it? Yeah. The initializer for module bottom. That's what's in it. How amusing. So what's in, is the initializer for module top in there? No. Nope. Huh. Well, that's interesting. It's successfully linked regardless. All right. Um, anyway, I verified that if I hand build everything in the appropriate order, that this works. And that's okay. I should commit what I currently have just because it does actually handle everything. Now, almost everything. All right. By the way, I use Mercurial. Well, it was nice having you here. Uh, thanks. And it was fun talking to you. And have a good evening. Stop doing stuff. Let's see here. LMDB. That's what it recommends. And I remember I've actually done this research before. I just forgot the name of what it is. Yes. Well, that's not what I want. I don't want a web API. Yeah, this is probably what I want. Uh, let's see here. The reason why I want LMDB, why I need this, is because in my cache, I need to record things about, okay, I'm compiling a module from this source file and this destination, or I'm compiling a module from this source. Has the source been updated uh, since the last time I compiled this module? If it hasn't been updated since the last time I compiled this module, then um, yeah, if it hasn't been updated since the last time I compiled this module, then we update it. Um, we recompile it. But if it hasn't been updated since the last time I compiled this module, then we don't, which means I need some kind of database of to know. Um, make just relies like make just relies on timestamps, and I don't want to rely just on timestamps. I want to use the full metadata for the thing, the size, the last modified date, um, the creation date if there is one. Uh, I think that's it. Um, that's what I want. Uh, so yeah, and so I need a database to store that all in, and that's what I'm going to be doing here. Another question to ask Junie. Ah, yeah, I don't want PyPy support. I don't care about CFFI. So I can just probably just pretend not to care. Um, well, none of this is very helpful. Ah, Map size, subdir, metasync. I want metasync false because for this particular database, it's not that important. I want right map is true as well. Why did that get put in here? I don't want that in here. I don't need type alias anymore. Um, all right. Let's see here. what do I call it? Call it okay. Oh, I see. Yeah, yeah, yeah. All right. Let's see here. And then it says with n dot begin as txn. So there's put and replace, but no documentation on what put or replace mean. No, 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 no. Oh, this is interesting. Well, that's very interesting. Hmm. Well, that's interesting. Simply creating the database somehow seems to have ended up with, hmm. This is going to require a bunch more research on my part to figure out how to use it. Pretty sure this is what I want to use. It looks like it does what I want it to do. But there's something I'm not understanding about what's going on here. Why do I have all these readers? They don't have transaction IDs associated with them. How do I get rid of the readers? Why does set have a permissions problem? Why am I not allowed to use? But it's not. Yeah, it's not read only. I didn't open it in read only mode. Huh. Yeah. Need to understand what the heck is going on here. Oh, I see. There we go. All right. Oh, hi there. Uh, I am fiddling around with LMDB because I am writing a Python implementation of the GNU C++ module mapper interface thingy. And I need to have a database in which I store file metadata, um, so that I can determine whether the input file has changed since the last time I compiled it. So that's what this is. That's what I'm fiddling with right now. I'm actually about to log out. I have a social function in 15 minutes. I have looked at your thing a little bit. I don't have any strong opinions about it yet. I need to look at it some more. Um, but yes, and I'm going to write down one of my. I'm just putting this in here so that I have some usage information, so that it's basically a bit of documentation on how to use LMDB next time I come back to this. I've been asking Junie all about it. Uh, it's very difficult to get Junie to not try to edit your code. It's kind of annoying. Anyway, it was good seeing you, and I'm sorry to that the stream's going to be ending about the time you show up, but I hope to see you next time. I'm not going to make any strong predictions about next time. I hope Thursday, but I'm not sure. I hope that you have an excellent rest of your evening, Mr. Elfman. Are you at all interested in C++ modules, by the way? All right, then. I'm beginning a journey. Although I should return to the language implementation at some point in time as well. Kind of want to implement data types. They're like composite data types, and maybe also add a string type. And then I think I'm going to be done with it. But for now, I'm fiddling with modules in C++ for a different